We're going to start our polynomial first section on this video. So we're going to talk about naming and categorizing polynomials, something just really important, just verbiage. And then we're going to talk about end behavior, which is really crucial for when we start graphing without our calculator. So again, as a review, polynomial means many terms. And I'm looking for my variable to be raised to some degree. Now this degree has many qualifications. It has to be a whole number. And that number needs to be greater than or equal to 0. You can technically have 0 because x raised to the 0 is equal to 1. 1 is considered a polynomial because it's linear. It's not linear, it is a constant term. So this is possible to have, would be considered a polynomial. So let's kind of get to it. I've given you a bunch of examples. Can you determine which of these are polynomials and which ones aren't? So pause the video now and check. All right, so hopefully you came up with the same thing I did. So notice this 2/3 and then square root of 3. These would not work as an exponent. However, because they're just coefficients, it doesn't matter. These are still considered polynomials. Now, if you go over here, I can't have x to the -3 because if you remember, -3 is less than 0, but x to the -3 is actually x cubed. So this would be 2 times 1 over x cubed. This is, of course, a rational. Now, rational is composed of 2 polynomials. And then this square root is actually x plus 5. And if you put it as an exponent, it's raised to the 1/2. Again, not a whole number. It is larger than 0, but it's not a whole number. So that's why those are not polynomials. So what's something, something super important about polynomials is that they have to be in standard form. So just like when we looked at quadratics, they had to be in descending order. Now, we didn't really necessarily say that, but all that means is find your largest degree, and that goes first. So this is 2x to the 5th. Then go down from there. So what's my next lowest degree? What's my next lowest degree? What's my next? So hopefully what you would find is that if you indeed found these in descending order, I go 5, 3, 1, technically, and this would technically be x to the 0. So this would be in descending order. Pretty straightforward. So let's talk about how we can name them by degree and then talk about number of terms. So this number of terms is just some really precise vocabulary. So when I have a degree of 0, this is a constant term. I'm looking at something like 5, 10, 1, okay? When I've got one term, this is considered a monomial, right? 1, mono, singular. 2, so when I look at degree 1, this is a linear function, right? X to the 1. This would be a line. Notice I've got one term and 2 terms, so this is a binomial. I've got a quadratic here. I've got x squared, right? My degree is 2. Notice again, I've only got one term, so monomial. I've got a cubic. My degree is 3. That's my largest degree, so I call it a cubic. I've got 1, 2, 3 terms now, so this is a trinomial. The quartic, I've got a degree of 4, but I've only got 2 terms, so this is a binomial with a degree of 4, so it's quartic. And then last but not least, I've got quintic, so I've got a degree of 5, but notice I've got 1, 2, 3, 4, so no, you don't have to call it a quadnomial, it's actually just a polynomial from here. So anything over 3, polynomial. 1, monomial. 2, binomial. 3, trinomial. 4 or more, polynomial. This 4 terms, not really relevant. So what I want you to do now is I want you to name this by degree and by the number of terms. So in this first box, when I've got a degree of 4 and I've got 1, 2, 3 terms, this would in fact be a quartic trinomial. So I want you to do that for the rest. So pause here and see if you can figure them out. So after I move the box, you should hopefully agree with these different answers. So if you have a question, let me know. I am in class today, but hopefully this is straightforward. Refer to your chart if you're a little bit confused. So from here, what I want you to do is I want you to look at these different polynomials, and I want you to make a rough, okay, keyword rough. I don't need any points. I just want you to be like, blah. Now, obviously, that's not what it looks like, but that's all I'm looking for, okay? Make sure you take your blah and put arrows on it, but that's all I'm really looking for. So make a rough sketch, hit zoom 6 to make sure it's in standard zoom. That way you can see the whole thing. And I want you to look at these different ones And then read this down here, crucial, okay? So pause the video now and work on that. From here, hopefully you got similar rough views in your calculator. So what I wanted you to notice is that when I have a degree that is even, right, 2, 4, 6, that means that I am going to have graphs that are both, my end behavior is going the same direction. So they're each both going like up and up, or they're going down and down. So notice this one's, both of them are pointing down, both of them are pointing up, both of them are pointing up. So when you look at the odd, hopefully what you notice is that, I can't scroll down for some reason, that I have 1, right, 3, 5, 7, that they are going opposite directions. So my end behavior is looking like sometimes it's down then up, and sometimes it's up then down. So let's look at specifically. So notice these two have the same exact end behavior, even though they're different degrees. It's because their leading coefficient is positive. There's no negative here. Now look, I've got a negative. It doesn't matter that it's a fraction. This will reverse the way that it looks. Notice here, right? I'm used to my quadratic going like this. Well, when it's negative, now it's going down. So that's all that's happening here. Regardless of the degree, even or odd, if it is negative in a even, it's going to be flipped upside down, and in an odd, it's going to be going up then down. So let's kind of fill on this chart. So when I'm talking about end behavior, if it's even and positive, I'm going up and up. What happens in between here is dependent on the degree, right? When I'm negative, my graph is going down and down. Doesn't matter what's going on in here, but that's what my end behavior is doing. So I'm talking about odd. What I want you to think about is think about just your x cubed function. I'm going something like this, right? I'm starting down and going up. So if you ever forget, think about your normal x cubed. So if I'm making this a negative x cubed, I'm just doing the opposite. I'm going up, then I'm going down. So of course there's going to be fancy notation for that. So if you think about your coordinate plane, and you think about just like an x squared and an x cubed. Okay, so I think about my positive x squared. As x is approaching negative infinity, so as I'm going this direction, right, following along my x, my y value is also going to infinity, right? I'm going up. When I think about as x is going towards positive infinity, so I'm going this way. Notice my graph is also going up, so this y is also going to infinity. Now if I made this a negative x squared, now I'm looking at this. I'm going down, right? Down, down. So as I'm approaching negative infinity, right, as my x values are going this way, I'm also going down. So this would be towards negative infinity. So negative infinity, and obviously because they're both going the same direction as my x goes this way, I am going towards positive, my y is also going towards negative infinity. Now let's think about our x cubed graph. So if it's going like this, positive, as my x values, so notice these are going to be opposite, right? On my quadratic, they're both going the same direction, so they're both towards infinity, or both towards negative infinity. But on my cubed, I'm going to be looking at two opposite directions. So as I am approaching my negative x values, my graph is going down towards negative infinity, right? If I label these infinity. And then as my x is approaching infinity, right, I'm going this direction, my y is shooting up. So this is going towards positive infinity. And if I think about my opposite, right, I'm going like this. So as I'm approaching negative infinity this way, my y is going up towards positive infinity. And as my x is going towards positive infinity, my y is traveling down. So this is going towards negative infinity. So this will be fancy notation. We'll continue working on it, but I want you to be aware that that is how you're going to see your questions. Whoa, whoa. So on these next two questions, what I want you to do is I want you to pause the video, and I want you, without a calculator, to solve these questions. Okay, so pause the video. Can you figure out which graph is associated to the correct polynomial? So hopefully you got this right? This is 23, This is 25, this is 24, this is 26.